So we are propagating this thing now. We know the column index that we need. This is actually done before. So the last thing that's left is to tie everything together and face our fears and see this thing that was failing before. Oh, we are already at the root page. And we are parsing the header and count rows. So we have number of cells in here and we were printing it. Oh, okay, so we don't need this. We only did it because for the count. Okay, now I remember. So we can do the seek to page again like we did before. We're doing it to the root page of this one, of this table. And now we can read the whole table. Using parse record from page. And then this probably not gonna work. I don't know. Let's see what it's gonna give us. But what we need is in the table we'll have records, and then we'll have to traverse those. This. Each one is a column. No, each one is a row or record. And then the record has columns, and we need to get them. Can we do it like this? Can we get const value at this position, at the one that we just got in here? This is supposed to... How do we... Is that returning optional? Probably not. Probably fails. And it's probably not what we want or need. Yeah, I don't think we've done this. Column, is it possible for it to fail? I mean, it is. And if it fails, I mean, the error is gonna be ugly. Can we do try catch? I think this would be important soon. And then yeah, we just get that and we print that value. That's it. In theory. In theory, if this works, it works. But there are multiple things that can go wrong, and they probably will. So first of all, this is... Oh, this also needs to be... This also can fail. Oh, okay, so here we do need a type. So we need to know... Okay, so we do need to pass a type. I was speculating... column type. And then depending on the type, we're gonna know what function to call here. Okay, I think that makes sense. Hell yeah. Beautiful. So this is complete trash that we're doing then. Complete trash. Yeah, let's start looking at one by one. Root page 2. Oh. Yeah, I mean, seek to page 2 makes sense. Because if I do oranges, it should be the other one. Yeah, 4. And here's the error is different, but it doesn't matter. It's just we're completely off with something. This is me from the future. I managed not to record the voice for the rest of the video, so I have to go back and look at the footage and talk as it goes, so it's not just random coding. The good news is that I can speed up the coding, so it's done faster. The bad news is I'll have to try to catch up and try to talk about what was going on, and I don't promise that it's going to be as coherent and as real time as it usually is. I mean, it might be louder, it might be better, but so at this point I'm still trying to debug what happened. I was trying to print the number of cells and the pointers themselves, and I was thinking, okay, maybe the offsets are wrong, and I think I was missing a page. That was my theory, and the theory was correct. So now I'm gonna print some stuff, and I'm gonna see that I was trying to print pointers as strings, but pointers are need to be integers, and then number of cells is going to be the same error. Now it's going to compile, and now we're going to see that the pointers look reasonable. The previous cells we saw before when we were debugging it for a while, and those look reasonable as well. They go in opposite direction, so it kind of makes sense. I'm just trying to convert and see if we are off or not, and what we're actually reading. So I'm going to do a hex dump. I'm going to take a look that the one that we got were somewhere on the first page or the second page, depends how you count. But what we're looking for is this page, the root page 2 for the apples and stuff. And I go back and see like, okay, we have a 1000 difference in hex, which is 4096, which is a whole page. So we are a whole page off. Somehow we're not taking a page into account. And the idea is that the problem is this goddamn interface that we are using instead of looking at the proper page. And the rest, I don't know, not the rest. For the next 20 minutes, we'll have to refactor and switch from the reader to a slice of bytes just to look at one page. We know that the page is 4096 bytes, and we can parse it for each page and pass it along. And now I'm trying to figure out which direction to go, which to approach, because a lot of the interface is broke. And those comments are going to be useful. The debugging is going to be useful later, so we can check if we get the same results, at least for the things that used to work before. So the seek page is not working anymore. We'll have to switch to get page. So we still pass a reader and a root page and a page size, but instead of returning void and moving the pointers away, we're going to return we're going to return data. We're going to return the whole page. Here I'm thinking if I could be sneaky and make it in compile time, because I know it's going to be 4096, but we do read page size and we do return it. So it's kind of sneaky and we cannot really trust it. So I'm kind of going back and forth thinking maybe I should enforce this on compile time, but then I just give up and decide that like, okay, let's pass an allocator. Let's allocate 4096 bytes and just use it in here. So we'll just allocate a whole page size. I'm gonna change this, I think, into using the different method later, but the idea is the same. We have a page and then we need to try it. Okay, that one was off. Imagine we return it. Just double checking the types that we do return a string or a list of a slice of bytes and not just bytes. So what's interesting here is that I'm removing the seek, but I do need a seek, so it's gonna go back. Here remember that there was read alloc, so you can allocate and return at the same time. As I mentioned, the first page is gonna be removed. Once again, double checking, removing, and then passing the allocator and the page size, and the result is what we want, the whole page. It's gonna allocate it and we're going to return it. Now we don't need the seek2 page anymore. I'm gonna remove it later, but just keeping it for now in case I have to go back. I made in the reference in here, but I'm gonna remove it later, don't worry. So now the method is gone and we have to use the get page. So the first page is gonna be just read. It's going to be just get page with the allocator, with the reader as we had before. So we pass the reader. The root page is 1 and page size is page size. I think we parsed it already before. We can pass a page size. And now we need to pass the first page into the parse instead of the interface instead of the reader interface. So now let's see what's going to break. We already adjusted that. We can pass it around in other places so we don't forget. We pass the root page that we parsed in the schema, and the same for select. In this case page, this also breaks the parse one because we need to implement it. And then the parse the whole record also needs a page. We just tested this. I think this one is the simpler one, the parse header count. And I think we changed this before already, but we do need to change it again to work with slices. So the first one is easy. We have a page and we need just the first byte. And then we have to retrofit and remember what we had. So we had seek2 means seek2 plus 2 means kind of 3 to 5. This is not going to work, so we'll have to change it later. But now I'm thinking about seek by 3. It's more or less 5 plus 3, so you get an 8. And I don't remember which one is which, so I'm trying to remember is interior page from 8. I'm gonna just give up and change the response type because I have to think, right, depending of if we had the interior, we either read the 8 bytes only and then we go right away to the body, or if we read those 8 plus 4, I think it was 4, it means we read a bit more. So we need to know how much we read and how much we have. So here I'm looking up, I want to return the anonymous struct. And for now, we're going to return number of rows as we did before, plus read bytes, but we're going to change it just in a couple of minutes. Here I'm trying to remember how to do if expressions and return maybe number of rows in this case. But I'm changing my mind and realizing that doesn't make sense to return the offset if we can already return the rest. Like similar as people do with parser, you take things that needs to be parsed, you return the useful part plus the rest. And I think this works in this case pretty well. If we consumed the header with 4 bytes at the end or we didn't, it doesn't matter. We return the body for the rest to proceed because it's not relevant. I mean, it is relevant, but not in our case where we just throw it away. So I see that this interface might work. I mean, this approach was else with returning the whole struct, but I'm not happy with all the copying. I'm thinking that I want to try to return only the record body, this page rest, and then return the struct at the bottom. This is not going to work. This is not how Zeek allows you to do if expressions. This is just a statement, but we'll change it later when it doesn't compile. In this case, it just gets thrown away. And now we quickly look at the docs and verify that everything is as expected. So first one, offset 0, size 1. Then we look at the 2 from 3 to 5. Once again, that's not going to work. We'll have to change it later when it doesn't compile. But the idea is from 3 to 5. And then we look at the last offset 8 and we take 4. If it's interior, we do take it. And if it's not, then no, it's just omitted. So if we took it, it means we need to go from 12. Okay, let's go to the full screen and finish this up. What else doesn't compile? Here we pass the page as we did. It should work, but now we have to adopt the result because now we don't return just number of cells, we return the number of cells plus the rest. I'm trying to remember if there is a way to deconstruct the structs, and I think I was laughing because the destructing has a struct in it, but there is no the destructing for structs. At least I couldn't find anything. So I just give up and call it the result. Then we can use the result in a couple of places. I realize that the n cells is we can just reuse the previous name. Okay, that's not needed. we can print this, and it's nice to see this issue. We'll see if we have any issues or not, and then instead of number of cells, we just replace everything else with new result. And here it's more interesting. I'll jump back and forth on this for a while, but I had the idea that, okay, we have an I, right? We start from 0, and then we need to take 2 bytes. So 0 plus 2 is going to be 2. But then I realized that the next one is not going to be from 1, it's going to be from 2. So we need to increase I by 2. But then it doesn't work with 4. And I was thinking, should I rewrite 4 to a while loop? Should I rewrite it to a different 4 that has a different iterator? But then I have but then I have an idea. What if I just write it as it should be and try to see a pattern? So what we're trying to do is 0 to 2, 2 to 4, and 4 to 6. So we operating on I multiplied by 2s, having the slices like this, and I as 0, 1, and 2. We can see that we need to multiply by 2 to get the first one, and then we can I by 2 plus 2 to get the rest of it. So I do keep the I. I'm thinking maybe I should call it offset or J, but I don't. I just I by 2 by I plus I by 2 plus 2. And it does work. And then we replace this number of cells in the other case. In this case, I kind of think, oh wait, we do need offset. We did this I, do we need to start from that I where we stopped? It takes me, I don't know, 30 seconds to remember that offsets are independent, and that's why we started the whole thing, because offsets were independent. So I'm gonna try to add a variable for I, and then I'm gonna remove it in a bit. But that's the whole thing. Those cells and the header, the parse header, and then offsets, the cell pointer array, they start as a page start, and you read it sequentially. But then when you go to offsets, you have to switch. They're kind of independent. They're not relative, they're kind of absolute. And that's one of the things that tripped me up a bit in this whole thing. That's why it was refactored 2 or 3 times. But that's the main issue, that you have to treat those separately, and if you treat those separately, it's going to work. And I promise you, in the next 30 minutes, you're gonna see that it does work. But the question is, like, still, how do we do? We used to do seeks, and what do we do now? Can we remove the hack or not? And we can, and it's gonna be much nicer and simpler. So we don't need to seek, we don't need this, and we don't even need that. We have a page, and we know that in this page, we have an offset. So we start from the offset, and we can go to the end. It doesn't really matter what the rest is. We're going to consume only what we need from the offset. We don't need to allocate or get most of the stuff. I'm just adding a print here to see what we're going to get, but the solution is just one-liner. And then we run, and we see a couple of errors. So the first thing, as I mentioned, the allocator was passed by reference, but it should be passed by value. And it's because the allocator itself is holding the reference. So when we copy in the allocator, we copy in the value, it's just going to copy the reference. So it's fine. And here, as I mentioned before as well, as I alluded before, this not working. It would need to be something like this to work. But I try to remember that maybe if we inline, it's going to work, and it will. This is enough to turn this into an if expression, and it looks pretty neat as well. And now we go back to this interesting thing. Oh no, I thought I'm going to change the other one, but I didn't change the other. I changed this one. This is where it changed, because it wants to know in compile times that we have 2 bytes, but we have a slice because we create a slice. It doesn't know that this slice is only 2 bytes. Like, even though we have like whatever index on the left and whatever index plus 2 on the right. I'm going to try to refactor it to use that. It's not going to work. And then I'm going to try another hack, and it will work. But actually, I'm not sure it's a hack. I think it's elegant the way it's going to work. So the first attempt is to have some sort of J of usize. Change it to a usize, I think. Yeah, usize. And then tell it that, okay, the next one is going to be plus 2. The compiler isn't going to like it. But then I think, what if I do 2 slices? For the first time I tell you like, okay, start from J, because that usually works, right? And then the second one I tell you like, just take 2. And it does work. Now there's a couple of issues with formatters. In the first case, I did find the link to where it fails, and it was because we were printing a record. Oh, first thing that I saw is maybe because of anonymous struct it doesn't work, but it's related to printing because we are printing the thing using S, but it should be any because it's a struct. But I ended up keeping this anyways. It's a bit different, but not much different. Now I'm gonna try and it's gonna fail again because it wasn't the real issue. The real issue is right there in the error, a bit lower. Yep. It's a bit lower right here. Right here in the main. Because number of cells right now is a struct. It's not number of cells, it's a result. And this is gonna bite us in that. And remember that place, because it's gonna bite us pretty bad. And interesting that the second case it's a similar issue, but there is no, like this references is hidden. It's not in the stack trace. But I do find it. And now it compiles, but it gives garbage results. And they are really bad. we can see that number of cells is 3. It means that we do go to the correct page and we do parse the page correctly. But the problem is that, as I alluded before, yeah, this is correct. So it did work for the first one, but somehow it failed. As I alluded before, we were mixing the offsets and you see index out of bounds, 11s, 111. We were mixing the offsets on the cell pointers because those offsets are coming from the page start. And right now we have a bit of a mix of how we get the page, and it does a bit more than just getting the page. And it's gonna take me a while to find it, but so I'm thinking like, okay, maybe if I print the page and see what it looks like, I'm gonna see why it's pointing there. But it's not much useful. Like you can see that it points to color text, a bit of a random place. It doesn't give you much. So I'm thinking, okay, where is the out of bounds? It's here. Maybe there is something I could see here. Maybe let's print and see what's wrong, like what did we pass? But it doesn't really help because we already looked at the color text. It's not very useful. But let's just wait. I'm gonna figure it out. I'm gonna look at some other part. Also, length is not very helpful, and I'm gonna do it twice. And 9 in hexadecimal is the same 9, so it's completely painful to watch in the recording. Like the whole action is not useful, and then on top of that, I'm like, yeah, length is 9, then it's 9. And then I'm thinking, okay, oh, maybe I need to go a level up and look at the cell, but it's gonna be similar. It's not correct. It's not very helpful to look at this. It's like, okay, 113. Okay. We're off. There's a... We go a bit past it. It's not very helpful. Okay, here I'm realizing that I'm looking at this and it's useless. And I'm thinking, okay, so we are really off. What are we doing? And I go to the page and I'm thinking, okay, if we're doing the header correct on the first page, it might be something that we are not lucky with other pages. So I'm looking at get page and I'm like, file header. This one is a bit off. Because we are lucky in this case and it does work. But then in other cases, we don't need that. This logic needs to move. Something, what if we do the same here when we parse the page later. So I take it out of here, I put a 0. Oh, actually, I think I didn't remove it later. I need to remove it. And I'm thinking, okay, what if I do this here in the parse header? Because otherwise, if we keep it, we cut that out of the page, and those offsets are working from 0, not from after those 100. And I think we looked at this before, and I think even people wrote in the comments, and now we neglected this. So now we need to make sure that we take this 100 into account when we look at the header, but we don't take this 100 into account when we're looking at the cell offsets. So moving this code here, it's going to require to pass root page everywhere now, because I just compared the page and it's like, oh no, I need the root page, not a page. I'm going to add the root page here, and I have to add it in a couple of places. This I64 is really weird. I think I need to make a better type for it, because it makes no sense. I think it is parsed as I64 in the docs or in the thing, but it's logically cannot go into -1 page. So I think we can remove the sign on there because it's not useful. Okay, a bit more plumbing, and I think one more here. In the first case, it's 1, and it works. And as you can see, it works all the way right away. I get really excited here. I start removing stuff, thinking about how great it's gonna be, and I'm thinking about submitting, but we're still missing a couple of parts. We're missing more than a couple of parts. There was at least 1 or 2 bugs that we introduced, and there's one logical thing that we're missing. I'm not sure it's needed for submission, but we're still missing the whole data type thing. I'm not removing all the comments because I'm thinking as well. No, I'm removing the comments, but I'm not removing all the debugs because I'm thinking that might be useful because I'm not trusting that it's going to work. And I even add a comment. Wow. I'll just go and I think copy it from the docs. Because it's already had to redo it 2 times. I'm thinking if I have to redo it the 3rd time, I might as well have a comment. And happily removing the hack that was there for, I don't know, 13 episodes. If I can call those episodes. But it's gonna fail. It's gonna fail like on the first initial test. And look at the error. It says that SQL error on our case, and then you can see that SQL that we printed, and the SQL that we printed has a select and from in lowercase. Here I'm cursing on my parser. But solution is simple. We just need case-insensitive comparison on strings. Comparison, I don't think any of the debug logs were useful in those debugging sessions. Just the error at the end was like had enough information, so that's also nice. So I get the code and I try to see if there is like a quality that allows you to tell you. I'm checking the same module to see anything case insensitive, but I don't find it. And now I go to the place that only a couple of dead souls go to. I go to Stack Overflow and they tell me. And they tell me that I can use the ASCII ignore case equality. And I think that's enough for me. I don't need the whole UTF. And so instead of standard memory mount, we just use the ASCII version, and it compares 2 strings and allows us to ignore the case. I tested, even though it shouldn't work, just to see if it compiles or not. And yes, we don't have to paste. We don't have to pass the byte type. And I'm going to replace a couple of cases. I'm going to get the same error. And now it passes. I think it makes sense to replace the create and table, so just go and replace all of them. So replaces all of them and submit. But I think I might have missed some, and I'm not sure it's the most robust parsing. I think that's the funniest parser I ever wrote, but it does the job. With the next submit, we can see this is whole error. I don't realize this is a whole error, like this whole bunch of noises is actually an error. I think that the bug got in there somehow, or I did something wrong with printing something useless. But if you look at it, it tries to get a count, and you can see the result has a number of cells and it has a record body. So it does print the whole struct. And I can reproduce it as well. This is what it prints. But I don't know. I think I kind of tired at this point and I don't pay attention. But the fix is simple. So I get panicky and start replacing all the debugs at this point. And I also remember that I forgot to do the data type in here. And I do get sidetracked and I decide, okay, maybe we do have to fix it right now. Because I think, oh, I remove all the debugs one, so it should work. So let's just fix this while we're here as well. So first thing I'm thinking is that maybe I should put a struct inside the string hash map, but then I decide like let's just have two hash maps. It's fine. There's some benefits to one approach versus another one. But I decided to go with this one. API-wise, it might seem like you want to have them together because you're going to use them together. But this ends up not as bad to be used as well. So we're parsing it right here, and then we need to create another table. I mean, not another table. I mean, technically, this is a dictionary table. Wait, do people call maps tables? I mean, it is a lookup table, so it is a table. But we need to return column types. And I did a copy paste with string hash map usize, but the compiler is not gonna like it, so we'll have to fix it anyway. I need to change it to the data type, SQL data type. And interesting here is that the compiler tells me that this is not public. Like I was using it before, and it was fine, but I think because we return it now, it needs to be public because we're gonna return it. But we didn't do it on the function, so that's the interesting part. So here's the usage. So you might think like, oh, okay, you parameterize there, and then you have to do it again. But we do need to do it again, but also it's a different error. Like if it's not there, different switch. I'm trying to be optimistic here and think that maybe if I do a switch or a pattern match on the optional value, I'm gonna have an option to do, I don't know, like in TypeScript or I don't know, Scala or Haskell, that I can say, oh, ADT, like those enums, or null, but it's not gonna work. So I'll have to change it. There might be a way to do this, but I don't think. And we need to print the, I mean, it's not really needed here or SQL, but it doesn't hurt to have consistency and make sure that when you get an error, you get as much context as possible. So I'm gonna get it anyways. And if I print it, it's gonna tell us that you're trying to switch on the optional, but it's like it. So then I try to unwrap it, but then the null is not needed on 75, but I'm trying, this is the thing I'm least happy with, is the nestedness of things. Like it goes from 66, it goes 1, and then 68, 2, and then 4, 3, and then switch 4, and now it's going to be kind of another one. So like 5 levels of nestedness. Not a big fan of this, and I don't know how to make it better, and maybe it's fine, but I'm kind of more used to more flat things. More, like this would be one enum, and those ifs would also be on the same level, like in my perfect world. And here I realize that the error is the same print. I'm gonna go back to this later, but on the enums, maybe I'll figure out by the end of this how to make it better. But not yet. And here I realize, oh yes, number of cells needs number of cells. It's not even number of cells, it should be a result. And that was an issue. But here we get into another one. And this one is also very interesting. As you can see, we have the same 4, 5, 5 on the left, 5 on the right. And it was saying usually that it doesn't care about order, but it seems like at this point it does care about the order. And I'm trying to run with my sample, and I see also that oranges come before apples, and I realized that I need to sort it. I wasn't sure if it's gonna work, and it was like here with new lines and spaces, it's not clear, but it is pretty. I don't know, if you look at the pattern and squint, you see that one is ordered, the other one's not, and that's the only series that I had. So I thought, okay, let's order it, because we did have them in lists before, and now we have them in a hash map. Hash map pre-orders those, so we had to. Maybe we should use sorted map next time. No, anyways, we do need to reorder and print those properly, so that's the next thing I'm gonna fix. So how does one sort in Zeek? I look for sort and I find 2 modules that are interesting. I see a couple of sorts also on one of the ArrayLeads implementations, and there is something also for hash maps, but that's not what we need. We're gonna go more lower level on our sorting. Here I see comparators, like the one that you pass 2 things and it's going to give you if it's sorted, compare them. We're going to try to use it, but it's not going to work. We'll have to use this one, just the whole sorting module. And we'll have to pass our custom comparator function for checking equality. But first thing, we need to get this out of the map into slice. I do consider array list for a second, I think, or maybe not. But yeah, I just put it in the. Just put it in the slice, into the array. It's not gonna work because I need strings and I also need a try. Here also try to get index, but it's not gonna work. We use optional iterator. It's not gonna take. I mean, it might, but I didn't make it work this time. So I have to create a separate I to iterate over, separate index, and increment it. I think here I think about array list. I think maybe that would be easy because I don't need an index, I can just append. But I realized like, no, it's fine. I know the links. Yeah, remember the length? We'll go back to length later. So this is a sort. We have stable and unstable. We don't need stable one because we just need names and we shouldn't have the same table names anyways. So we're gonna use stable version, unstable version. The type is strings, items is our result. The context, we don't need anything. So I'm looking at the usage, trying to figure out if anybody passing anything useful in the context. But I don't find anything. I'm just gonna put empty struct in there. And this is the more interesting thing, that we need a function. And I'm thinking, oh, maybe there was the sort one that I saw. Maybe it's gonna be enough. Just do it, compare it. That's all I want. Just compare the strings for me, thanks. Here I realized that the try was missing. And I think that wouldn't it be nice to print it before and after and see the results? Because I don't trust my functions. And that would prove very useful. So we run it, we're gonna see that the I is not happy about, so this should be just the U size. And then the U8 there should be a const of U8s. An array. Now we remember that that one needs to be the referenced. And now we see that the ascending thing is not working, and we do need to implement this. So I'm looking, for example, how to create a lambda. It's not a lambda, it's anonymous. I mean, it is like in Scala, you have a struct. No, it's more like a comparator. So we are passing the anonymous struct that implements that function, that implements that interface. We don't need the context, and I think we need to just compare the strings. And then we need to call that function. And that almost works. As you can see, we have oranges, apples, and then we have another before, and then a panic. So somehow we print two elements and then we blow up. And that's inside the result. Here I'm double checking that it doesn't get to this here option. It never gets there. It fails before. So it doesn't fail in sorting or after sorting. It fails even before, after we iterate it and put some stuff into our array, and then there is some leftovers in there. So we can see here that if we look at the keys, there's going to be only 2 keys. So this is not a problem with iterator, it's the problem with our array. Just a bit easier to see now. But we can see that we iterated on the 2 things, but then somehow we have 3 things. The only suspect here is length. And I'm looking at the length, I'm like, what am I looking at? Why am I looking at the iterator's length? It doesn't really, it's not really the thing you're looking at. We need the length of the map, and I'm looking, do we have a length, the size? Maybe count? It does have a count, and now it works. And here I'm like, what was the what was the length of the iterator to begin with? And it's gonna be 8. Yeah, so made sense that it had random stuff pre-allocated that we didn't need. And now it sorts, as you can see, apples and oranges. And instead of debug print, we can just print, but not with standard format. We need standard output, interface, and then we print that without after. That was interesting side quest. And I think with this, everything should work. And we finished the task. It wasn't so bad, only if it didn't took us 5 times longer than it should have.